These notes are on the inverse trigonometric functions. So the first one we're going to look at is the sine inverse function, so y equals sine inverse of x. And this translates into find the angle x when y is on the interval negative pi over 2 to pi over 2. And this part about the interval is a convention that we have. It's not necessarily, you could do it on other intervals. It's just that the way that our sine, cosine, and tan functions and sine inverse, cosine inverse, and tan inverse functions work is that this is the interval that we use. So I'm going to start by writing out my x and my sine function. Sine x function. However, I'm going to make one little adjustment here, which is I'm not going to start at 0. I'm actually going to start at negative pi over 2. And then I just follow my pattern 0, pi over 2, pi, 3 pi over 2, 2 pi, 0, 1, 0, negative 1, 0. And the reason why I added in this negative pi over 2 on the top of my table is because that is the y interval that I need. I need this interval. So, following the same pattern, negative pi over 2, sine of that is negative 1. Now, if you remember, finding the inverse of a function is reflecting over y equals x. So when I find my inverse here, so when I have x and y here, I switch these. So the x becomes negative 1 and the y becomes negative pi over 2. X becomes 0, y becomes 0, x becomes 1, y becomes pi over 2. So I can graph this, where now my x's are going to go from negative 1 to 1, and my y's are going to go from negative pi over 2 to positive pi over 2. So negative 1, negative pi over 2, 0, 0, positive 1, pi over 2. Oops, it's supposed to be a little curvy. And that's my function for y equals sine inverse x. Let's look at cosine inverse. So y equals cosine inverse x. Again, this is find angle x when y. However, in this case, the convention for this interval is from 0 to pi. Again, just a different convention. So again, I start with my x function, my cosine x function, 0, pi over 2, pi, 3 pi over 2, 2 pi. Of course, once I do the inverse, the reflection, I'm only looking from between 0 and pi, but filling in the table entirely for the cosine function is good practice and sort of helps me out. So the pattern for cosine is 1, 0, negative 1, 0, 1. When I perform my inverse, my x's and y's get switched. So my x becomes 1, my y becomes 0, my x becomes 0, my y becomes pi over 2, my x becomes negative 1, my y becomes pi. So again, my x's are negative 1 to 1, but my y's in this case are actually 0 to pi. So at positive 1, I'm at 0. At 0, I'm at pi over 2. And at negative 1, I'm at pi. And again, kind of a curvy graph. It's not a straight line. The last function that we need to find the inverse of is the tan function. So, whoops. Y equals tan inverse of x. So again, for this one, we're asking to find angle x when. Now, for the tan function, we actually use the same interval as the sine function. So negative pi over 2 to pi over 2. And again, these are conventions, but they have mathematical reasons why, and it has to do with the relationships between these three functions. So I'm going to start with a table, just as I have, of tan x, and I'm going to start my table at negative pi over 2, just like I did for my sine, because that way I can get the interval I'm looking for when I find my inverse, which is this interval here. Now, I don't memorize the tan function values. Instead, I remember that tan is sine over cosine. And so then I look back at my tables here and I say, well, sine over cosine, -1. Sine over cosine, oh, whoops, I've got it switched, sorry. I need to look at 0. So for 0, sine over cosine is 0 over 1, which is 0. I keep putting it in the wrong spot. For pi over 2, the sine over cosine is 1 over 0, which is undefined. For pi, it is 0 over -1, which is 0. For 3 pi over 2, it's -1 over 0, which is undefined. For 2 pi, it's 0 over 1, which is 0, which means following this pattern, my negative pi over 2 is going to be undefined. And then I graph it. Oh, sorry, I got to find the inverse. So when I flip my x's and y's, my x becomes undefined for a y of negative pi over 2. 0 becomes 0. Again, my x becomes undefined for a y over pi. Sorry, for y being pi. So in this case, this is kind of a little different because it kind of looks like I only have values for my x. The only value I can really graph is 0. But if you remember, tangent functions have asymptotes, and that's why we've got this undefined business. So it turns out that our asymptotes, our undefineds, are at pi over 2 and negative pi. And so I then can draw in the tan function using those asymptotes.